Now we're going to switch our attention to the strong deactivating groups. So unlike the activating groups, where we're looking for a feature that helps stabilize the intermediate, in the deactivating groups, what we're going to do is try to find something that is especially bad, something that slows the reaction down. So here we have nitrobenzene, and the full Lewis structure is drawn out so that you can see the formal positive charge on the nitrogen, formal negative charge on the oxygen. And again, we're going to compare the ortho and meta attacks with the knowledge that the para attack is essentially the same as the ortho attack, so we don't need to do that one. If we use our pi electrons and attack the electrophile and put the electrophile at the ortho position, we're going to end up with the positive charge up here on the top carbon. And we can draw resonance structures moving the pi electrons around the ring to put the positive charge on the other 3 carbon atoms of the ring. So these are the 3 resonance structures for ortho attack and para attack. Now let's go ahead and turn our attention to the meta attack. We use the pi electrons at the bottom of the ring, put the electrophile meta, and we find that we get the positive charge at the bottom of the ring, and resonance will move it 2 more times so we can get the positive charge here and here. So the opposite 3 carbons that we have for ortho and para. Ortho and para, here, here, and here, meta, these 3 positions. So now, if we look at both of these, you're not going to find anything especially good. But one thing that should be glaringly obvious is something that's especially bad, and that is a positive charge next to another positive charge. 2 adjacent positive charges are especially bad. So this particular resonance structure right here is what makes the ortho and para pathways so unfavored. What it does is it raises the energy of those 2 pathways to such a degree that they just don't happen. The meta pathway, on the other hand, is preferred because it avoids having the 2 positive charges next together. One thing that is important to mention here, though, is the fact that if you look at this meta pathway right here, there's still nothing especially stabilizing or especially good about it. And that tells us why the nitro group is deactivating.